All right. Hello. If you don't know what Moonlight is, we are the side project club at 42. So we meet every Wednesday at 7 p.m. And it's a great place to share your side projects, whether that's a for-profit company, a nonprofit, an open source tool, a video game, whatever that is. We meet here every Wednesday at 7, as well as we have a live stream you can watch online. And so normally, if you haven't been here before, the first part of the meeting, we have anyone, like an open mic. Anyone can come up, anyone can pitch. You have up to 5 minutes to get a great idea or a great chance to get feedback. The second half, we have a demo. So today, our demo is Isaac. What Isaac is showing off is a brute force method or brute force program he built to solve an AI board game. To solve a board game. So anyway, let's go ahead. Does anyone have any pitches, anything they want to talk about? Figured. Justin? All right, I'm going to assume that idea isn't appropriate for the YouTube live stream.
Well, no, so rather than Facebook selling your metadata, you sell your own metadata, so you make the money. Companies go to you directly. The joke is that the company I'm working for.
Oh, got you. Cool. All right, so we're good to move into the demo tonight? All right, let's go ahead and move into the demo. So Isaac should go ahead and set up, and he can kind of introduce you into what he's working on, how he solved that. Isaac.
Hello, I'm Isaac. So, who here has heard about chess? Who here knows how difficult it is for chess to actually be brute force and solved? I'm not going to solve chess. But I am going to solve another board game. It's an 8x8 with 2 players, black versus white, and it's called Reverse Eye or Othello, depending on how pedantic you want to be. The reason I'm choosing to brute force this rather than chess is because it has a finite number of moves per game, and it's provable that it's finite because every move that you make removes one of the squares from the board, so the game will terminate after the board is 64 squares, roughly 60 moves. If you skip a player, that might add a turn, but we'll just say under 70 moves. So because it's guaranteed to terminate within that space, I figure it's a much more reasonable space to brute force and calculate. And then once you've determined all the possible end game states, you know how many times black is won, how many times white is won, it becomes a tree problem to go back up and then know at any given point in the tree which move is most valuable for each player, and so on. So what I'm going to focus on right now is the first part, which is literally just the brute force of the entire game and a couple optimizations I came up with to have it calculate in a reasonable amount of time and a reasonable amount of space and avoid duplication. So this is the board right here. As you can see, you've got 2 players, black and white, and they start in the center of the board in a little cross pattern. Black moves first, like most 2-player games like Go or Reverse Eye. I think chess is the only one where white moves first. And then the way that they move, I'll get up here so I can kind of point it out, is that you have to place your new tile opposite an opponent's tile so that you flip the tile in the middle and any other tiles in the middle. So that's why it's called Reverse Eye, because you're literally reversing the tiles. When you play on the physical board, the tiles are double-sided, so you just reverse them along the way. And this can continue. You can flip any number of tiles as long as you place opposite them. So for example, white flips here, this middle one, if they move there, etc. And so these are some other examples that the Wikipedia gives for possible endgame states where you run out of moves before you've filled the entire board. So one of the main optimizations that I'm going to do, that I have done, and I can show you the code for it, is right now the very first move before any player has done anything, you've got 4 potential spaces available. But if you look, all of the moves are identical. No matter which move that you actually take, you always end up with this board state rotated somewhat, like think you rotate a Tetris piece. It's flipped, it's rotated. If you go here, the T is going to be that way. If you go here, the T is going to be upside down over here. Same thing. So just right off the bat, you can eliminate 3/4 of the move tree just by simplifying all flip duplicate moves into one move. and then at the end of the line being like, all right, well, instead of there just being one path to this end, there were 4 paths to this end because the first 4 moves were identical, and so on. And so as you go down throughout the program, it will eliminate any moves that it considers redundant. And so the way that I actually do that is if you break down the board has symmetries. And there are roughly 3 types of symmetries that you care about: vertical symmetry, horizontal symmetry, and rotational symmetry. And then with that, you can create a bit field from 0 to 8, something like that, where if it's one of the symmetries, it's 0 or 1, the other one it's 0 or 2, 0 or 4, and then you can get that to know by applying the bit mask, you can determine which symmetries are available. And so it'd be a lot easier to like whiteboard and explain than actually look at my code, because right now my code is just like I optimized it today just to get it running, and I got the basic presentation of it, but not much of a looker, but we can. At this point, does anyone have any questions before I continue? Yes.
Did you look at any open source reverse replaying AIs?
No. I'm not looking at existing AIs because okay, I take that back. I have looked at some existing AIs. The way that they do their calculations is they've weighted the spaces on the board such that the corners are worth the most, the spaces directly adjacent to the corners are worth the least, and then all of the other spaces have some number value attached to them. The thing with that is just because a space has like a specific weighting doesn't mean it's a good or bad move. That's just what mathematicians have found. And we think most games where you move here are better than other games. And they do all the math to prove it. But what they haven't done is they haven't beat the game 100%, so they don't know for sure. So that's what I'm going to do, is I'm going to actually get all of the stats on, like, not the spaces on the board, but the actual moves that are available to the players. Another question.
Are you going to publish?
Am I going to publish? I mean, I'm already publishing. It's on GitHub. You can fork it if you want. That's actually, okay, so this is the first part of 3. The first part of this project is the actual brute force, gather all the aggregate data. And I'm just about wrapping that up now. My next hurdle for that is literally making sure I have enough space on my computer. I've got 1 terabyte reserved for this project, but I don't know if that's actually going to be enough. The second part is a slow crawler, which will, again, do the tree problem, go to the leaf nodes, gather the information about that, populate the branches all the way to the top until you know from the top what is the weight of each individual move. And then the third part is putting it up on a website with an AI where you can play against the hardest AI in the world. Or if you're playing with a friend and you want to cheat, you can look at the little statistical layout of, oh, if I move here, here are the stats on this move. If they move there, et cetera. So that's the idea. So really, once I get this finished and I get it running and it's just doing the slow crawl for the couple months, I can write up the website so that by the time all the data is done, I've got the front end and it all just comes together. But for now, we just have the data. Yeah. I'm gonna look at open some code. So most of the optimizations right now have been in, I want to say, board dupes. And you can't see it because of the header. So, as you can see, that's really tiny, and you can't read that. So I'm going to find a way to make this somewhat readable. Actually, we don't need this anymore. And we can scrunch this because it's useless information. And okay, so all of this is like really unreadable, really bad variable names because I may not have been entirely sober when I wrote this specific portion. And I also just am a masochist, and I'm trying to make this norm. So I was avoiding having this line be out to here by making the variable names. I'm going to go back and redo this particular section. This is the second part. This is not the interesting part. I borked the terminal. Oh. Any other questions so far, or do we want? Yes. There's no what? Well, I could demonstrate it running and showing you, like, it's creating the actual directories and, like, it doesn't have the data being written to the file just yet, but I can demo. Actually, I can go ahead and just have that running up. So if we run this with a board size of 4, just because I don't want it to run forever, it will, as you notice, this is going through and populating the wah, wah. Okay, but if you look at this, if you pay attention to the actual individual lines, I don't think you can see this from here, but they don't increment straight one by one. They kind of make some jumps as it skips over the moves that it considers redundant. And this is like the full path to this line prints at the end of a game. And actually, what I'm pretty sure is happening here is we actually reach the end of the program, and it's like, you know, running through the cleanup steps, and somewhere in the part of me closing the program, I, you know, freed something twice or something like that. So this is actually a 4x4 solved right here in front of your face. Yeah. Thanks. We can go ahead and, if we want to spend a little more time, run through a 6x6, and it'd probably be here for the rest of the week. Or I'm kidding, it's probably only a couple of hours. But the 8x8 is probably going to be an unreasonable amount of time. And I'm just going to have my computer running for a couple days. Maybe I'll rent some AWS, like supercomputer speed, and like thread it or something. Yes, question? So right now, I'm trading a little bit of space for a little bit more manageability in that the actual moves, if you see this, this is a path name. So the first move is stored in this folder. And then from there, any subsequent moves, the branches are different folders. So then I can treat the directory file tree as my data tree, and then parsing it is just navigating the folders. That is going to take a significant chunk out of space, because I think each directory is going to be, what, 14, what is this? One of these numbers is how many bytes or something it takes. So yeah, folders take up 68 bytes. So each folder itself is going to be taking up more space on the hard drive, just for the purposes of like holding the file tree. And I mean, it'll be different on system to system, so I'm going to look at actually specifically formatting the drive in a way that the file system is as minimal as possible. Something Linux architecture. And yeah. Yes. Correct. Well, well, see, the thing is, it's not truly 64 factorial because so something that's like a little closer was for me 2 to the 64, because if you just assume 2 moves per turn, that's lowballing it, but 2 moves per turn and 64 turns makes more sense. And also, it's not truly 64, because if you look, the board starts with 4 squares already filled, so that's 2 to the 60. And then the first move we've already established is going to be the same all the way through, so it's 2 to the 59, or n to the 59, where n is the number of moves on that specific turn. So maybe 64 factorial might be a bit better estimate, but it's much closer to 60 or 59 factorial because of just those first 3 right there. It is going to be a while. It is going to be a lot of space and a lot of time. Yes.
Does it have CUDA support?
The question is, does it have CUDA support? It could. Unfortunately, the graphics card that I'm running is the economy line just below the drive that they start supporting for CUDA. Like, there's CUDA, and then the one right below is where mine sits. And so I'm like, I could get a new graphics card and give it CUDA support, but it currently doesn't. Is another question? Yes. Why not use a database instead of a file structure? That is a good question. I am at the point in this project where that is something I'm going to look at. Right now, this is just entirely in C, so if I can find a database library that I can just link in C and write that way, I'll do that. Until then, this is what I've got. Doing this from scratch, guys, so far. Yes?
Why did you use your libFT instead of a standard library?
Okay, so the question is, why did I use this libFT instead of a standard library? And the answer is,
Presumably it's more optimized.
presumably, not necessarily. Some of the functions side by side, standard library versus the library I wrote, standard library is more optimized because they're just calling inline assembly and doing it, you know, as fast as possible. You know, they'll write a 100-line function because the lines are mauve, you know, LD, you know, et cetera, et cetera. But you know what? I spent like several weeks writing that library, and I'm going to use it. That's just that. It's just habit at this point. Anything else? Sorry, I've kind of like hyped this up, and then we stared at a terminal the whole time, but that's... Do you have a question? Okay, cool. Well, this is my project. I'm...
Awesome. All right, thanks. That's it this week. If anyone wants to demo in the future, just come find me. My name is Jay Trejo on Slack. Thanks.